2 students, and today we will discuss and share information about freely or free falling bodies.
In this video, our main objective is to know the different formulas about free-falling bodies and how we are going to apply them when solving different problems.
Aside from the main objectives, our goals to achieve in this video about free-falling bodies are the following.
First, to know what is free-falling body. Second, to study the motion of a free-falling body. Third, to explain the concept of acceleration due to gravity. And lastly, to learn how to solve problems that involve falling objects due to acceleration of gravity. Free fall, which can also be called as one-dimensional vertical motion. We use the same equations of motion as before for the constant acceleration problems, or what we call rectilinear motion. However, the acceleration that we use in free fall is denoted as g, or the acceleration due to gravity. In free fall, there is no change in horizontal direction, only in the vertical direction as the object travels purely vertical.
When it comes to acceleration due to gravity, in the solar system, every planet has different gravity. When you're in Earth and near the Earth's surface, the gravity that we use is constant, 9.81 meter per second squared in terms of meters, and 32.2 feet per second squared in terms of feet.
Now, when it comes to equations and formulas, we will use the equations developed or created for rectilinear motion or the constant acceleration.
For the velocity at any time, we will use the equation velocity equals initial velocity plus the acceleration due to gravity multiplied by time.
Where v is equals to velocity or final velocity, v sub o is the initial velocity, g is the acceleration due to gravity, and t is the time. For the coordinate at any time, we will use the formula y equals initial velocity multiplied by time plus 1/2 acceleration due to gravity in meters or in feet multiplied by time squared. Wherein y is equals to distance or height, v sub o is the initial velocity, t is time, and g is the acceleration due to gravity.
For the velocity of any coordinate, we will use the formula v squared is equal to the initial velocity squared plus 2 multiplied by acceleration due to gravity multiplied by y.
In what real-life scenario we can apply free-falling bodies?
When two objects are dropped in a vacuum, they fall at the same rate regardless of the size and weight of the object. That is why in free fall, the mass of the object is not considered. When you drop a pen and a paper at the same elevation, we would observe that the pen would hit the ground faster than the paper. That is because of the presence of air. But when you drop a pen and a crumpled paper at the same elevation, we would observe that both objects would hit the ground at the same time, neglecting the presence of air.
So, we are done with our first three objectives. And now, let us achieve the fourth and the last one, which is to learn how to solve problems that involve falling objects due to the acceleration of gravity.
Let's try the sample problems. For the first problem, a tennis ball is thrown vertically downward with an initial velocity of 10 meters per second. Find its final velocity after 5 seconds and find the distance of the tennis ball during the 5 seconds. For the illustration of the problem, we have a tennis ball which is thrown vertically downward. It was thrown, which means it has a force. It has an initial velocity of 10 meters per second. And we're trying to find its final velocity with a given time of 5 seconds. We're also trying to find the distance of the tennis ball during the 5 seconds. Since the direction of the tennis ball is going downward, the gravity that we will use is a positive one in terms of meters. So we will use 9.81 meter per second squared. For the given, we have an initial velocity of 10 meter per second and a time of 5 seconds. With a gravity of positive 9.81 meter per second squared. For the required, we're trying to find its final velocity. Final velocity after 5 seconds. We're also trying to find the distance of the tennis ball during the 5 seconds. For letter A, we're going to use the first equation, where v is equals to the initial velocity plus gravity multiplied by time. For letter B, we're going to use the second equation, where y is equals to initial velocity multiplied by time plus 1/2 of gravity multiplied by time squared. For the solution, we're going to use the first equation, where v is equals to VO plus GT. So, substitute the given values. 10 meter per second plus 9.81 meter per second squared multiplied by 5 seconds. Now let's calculate using the given values. 10 plus 9.81 multiplied by 5. We got 59.05. So our unit will be meter per second. Since we got the final velocity, let's now calculate for the distance using the second equation. Y is equals to VOT plus 1/2 GT squared. Substitute the given values. (10 meter per second multiplied by 5 seconds plus 1/2 of 9.81 meter per second squared multiplied by 5 squared. Let's now calculate 10 multiplied by 5 plus 1/2 multiplied by 9.81 multiplied by 5 squared. We got 172.625 in terms of meters because it is a distance. For our final answers, we're going to use 2 decimal places. So for our final velocity, we've got 59.05 meter per second. And for our distance, we've got 172.63 meters. For the second problem, a stone is thrown vertically upward with an initial speed of 70 feet per second. A. How high does it go? B. Find the time to reach the maximum height. C. How many seconds after throwing will the stone be back at the ground? For the illustration of the problem, we got a stone which is thrown vertically upward. It has an initial velocity of 70 feet per second. When an object reaches its maximum height, it will come to a certain stop or rest, which means its final velocity will be 0. And for its downward movement, since it started from rest, its initial velocity will be 0. For the given, in the upward movement, we have an initial velocity of 70 feet per second, a final velocity of 0, and we have a gravity of negative 32.2 feet per second squared. Since the movement is upward, we have a negative gravity. And for the downward movement, we have an initial velocity of and a 0, gravity of positive 32.2 feet per second squared, and a gravity of positive 32.2 feet per second squared. For the required, at letter A, how high does it go? So we're required to find its distance. At letter B, find the time to reach the maximum height. And lastly, at letter C, how many seconds after throwing will the stone be back at the ground? So we're trying to find the total time it traveled. The equations that we are going to use are v squared is equals to vo squared plus 2gy. V is equals to vo plus gt. Y is equals to vot plus 1/2 gt squared. And lastly, total time is equal to 2 multiplied by t. Later you will see, since they are on about the same elevation, the time it traveled upward will be the same as the time it traveled downward. For the solution, at letter A, we're going to use the first equation. V squared is equals to vo squared plus 2gy. Since we're going to find the distance, we're going to manipulate the formula. V squared transpose vo squared is equals to 2gy. Then divide both sides by 2g. So we have y is equals to v squared minus vo squared over 2g. Now, substitute the given values. 0 squared minus 70 squared divided by 2 multiplied by negative 32.2. Let's now calculate the values. 0 squared minus 70 squared divided by 2 multiplied by negative 32.2. We're going to use 4 decimal places. So for the distance, we've got 76.0870 feet. For letter B, we're going to use the second formula. V is equals to VO plus GT. Again, we're going to manipulate the formula since we're trying to find the time. So we're going to use T is equals to V minus VO over G. Substitute the given values. 0 minus 70 divided by negative 32.2. Now calculate 0 minus 70 divided by negative 32.2. We've got 2.1739 seconds. At letter C, we're going to use the equation y is equals to VOT plus 1/2 GT squared. We're going to use this formula so that we can calculate for the time it traveled from the top up to the ground by using the velocity is equals to 0 and our formula will be 1/2 GT squared. Now, let's substitute the values. 76.0870 is equal to 1/2 multiplied by positive 32.2 feet per second squared multiplied by time squared. Now calculate. 76.0870 is equal to 1/2 multiplied by 32.2 multiplied by x squared. Shift solve and we've got 2.1739. If you notice, the time that it traveled upward and the time that it traveled downward is just the same. So we can use the formula total time is equal to 2t. Now, just substitute the value. Now calculate. 2 multiplied by 2.1739. We've got 4.3478. For the final answer, at letter A, we've got a distance of 76.09 feet. At letter B, we've got a time of 2.1739 seconds, or just simply 2.17 seconds. And at letter C, the total time that it traveled is 4.35 seconds.
So that's it. I hope that me and my group mates are able to explain the topic well, provide information, and provide helpful examples about freely or free falling bodies. With that, thank you so much and thank you for watching this video.